We would like to continue now with the founder of Jenkins, so to say. Yes. And we're very pleased that you are here and help us with understanding what Jenkins and Jenkins Enterprise is all about.
Thank you. So thank you very much. So I'm Kohsuke. I'm the creator of Jenkins, and I work on CloudBees. And so this is Jenkins project that I hack on day in, day out. Now, one of the things that the projects that occasionally do is the user survey. So I think every once a year, we ask a whole bunch of questions to the people. I hope some of you have already answered those. And as I was looking at one of the questions, and it turns out that in that answer, what's that bar? The 32% of the users said they only use master to do the builds, no slaves at all. So I was like, wow, some people really don't have any money. They can't even buy another computer. Then it turns out that in the same question, 18% of people said they have more than 50 slaves. 50 is a large number of computers, so I felt like, wow, I'm working for wrong company. Some people really do get lots of computers. I only get like 5 or 6 or whatever. And then I realized that, given that this is actually the answer to the same question, if you look at it, there's 1 in every 3 people seems to be doing any distributed build, as we call it. Only using one machine to do the build. And on the other hand, about 1 in 5 people are really using a large number of computers, right? To use the 50 computers to throw out the program, that's a pretty large scale. And then I thought that was the stark difference between these two audiences. And then, to me, it was a little bit unthinkable that the people actually do not use any slaves at all. So I wanted to today talk about why you should be doing this, and then what it leads to if you take it to the logical conclusion. Because it used to be that to actually have 50 computers to build the whole thing, you actually have to own 50 computers, and that's a lot of investment. But nowadays, you could actually very easily create 50 or even 500 computers, and it doesn't even cost all that much, so long as you're not keeping it on at the same time. So this ability that anyone could actually create more computers at the whim means we really actually need to be able to figure out how to use them well. It only used to be a problem for people like Google or Microsoft or that kind of things, but now it's actually a problem for all of us, because all of us could do it. So, this is my, so I wanted to talk about how I get there. So this is actually my first Jenkins instance. This is my first original Jenkins server, and that was around 2006. So this was like the unused Sun workstation. So it kind of looked nice from outside, but internally it wasn't all that powerful. So I was doing all my hacking in my laptop, but the company gives you some workstations. Like every year, the engineer is supposed to have a workstation, right? But I didn't have any use for it. So eventually, I decided to hack this software and then started using it. Slowly people around me started liking it. So at some point, I kept putting more jobs on this single computer. I think it actually has 2 CPU inside. But anyway, so at one point, it was actually running 6 builds and tests concurrently. And if you are trying to run 6 concurrent builds on 2 core system, like a dual socket single core system, you can imagine that this gets really, really slow. And so at one point, like my friend and colleague who came by and then said, Kohsuke, this is just way too slow. We can't keep adding more things in this system. You gotta do something about it. And he was right. And I like these challenges, And so one Christmas, I spent a whole bunch of time hacking the code and figured out how to add slaves into Jenkins. And then so, once I started adding slaves, the first slave actually I got from this was originally a broken computer, and then I called my corporate IT and they fixed it, so I effectively got it free. Anyway, so I kept adding these additional slaves, and going from 0 to 1 was actually hard. Not just because I had to code them, but because it makes you think a little bit differently about the environment. So here, when I had one computer, you like hard code or the path, like where the JDK is installed and stuff like that. But the second machine actually works very differently. This one is actually like AMD Opteron based, so it was a whole lot faster, but it was running newer versions. So anyway, so too much details. But so it does makes me sort of think of like an environment as somewhat independent thing, and then so it needed adjustment to the people. So I guess one of the cases that I wanted to pitch here is that I think you want, even if when you're starting using Jenkins, it kind of makes sense that you only have one computer, the master, to do the job. But because going to 0 to 1 is somewhat painful, I think it actually makes sense to just start with one slave if you could. But anyway, so going from 0 to 1 was hard, but from adding 1 to 2 was really easy. So I kept on adding more computers. And then my room kept getting warmer, like in this room. When you have lots of computers in the room, it really starts to feel the warmth. And I could really tell like when my cluster is busy because the room temperature would go up like 3 degrees. It's like, oh, people are really using the system, and so on. So I think that is one of the obvious reason why people should be doing the sort of the distributed or elastic field environment is that if you're doing it right, just to build your project and then run the tests, say a reasonable amount of tests on all your software, it should really require more than just one computer could handle. If you can't really, if what you're doing, unless what you're doing is really trivial, or maybe you don't really have any tests at all, then that's a problem on its own. But if you can't really figure out ways to effectively use these computers, I think you're doing something wrong. That there's that obvious reasons. So the building, testing of the components, but there's also more. If you think about what you can do if you have more computers, I think there's a whole lot more than that. So, there are, where I used to work in Sun, we had some tests that take a long time to run, like TCK compatibility testing, it was called, to make sure that the product conforms to the spec that's been written. That takes like hours, and some of them take weeks to run. The whole thing. So these things only get to run like, maybe every once in a week or once a month or even just once before the release. And then what happens when you run those tests less frequently, right? We don't know that when comes the time that we actually run it, like all sorts of things would break and then people would have to run left and right. So imagine you have more computers. You could run all these expensive tests all the time. So that would be nice. And in some places, people are taking it even one step further by running tests on every single commit individually. So that would take, maybe it could multiply the amount of computing resources you need, but it allows you to quickly identify the regression and pinpoint that to a single commit. And so that means people wouldn't have to play the blame game of figuring out who's responsible for this particular breakage. So you get to be a lot more productive that way. But at the same time, so you do want a lot of capacity, but then you don't want to build all the capacity to the point that you have this like a stadium-like environment where maybe only 2 hours in a whole week, the whole place gets packed, if you're lucky, and all the other time it's basically empty and no one is doing anything. And then because the continuous integration workload tends to be spiky, people tends to, if you're running some sort of, say, sprint, you can clearly see that toward the end of the sprint, everyone sort of try to rush in their changes, and then so the cluster would become busy. In the weekend, there's really nothing happens, so the whole cluster basically sits idle, wasting the energy and producing heat. Basically, the expensive heater is what it is. So I think that's sort of the one argument for why the elasticity is a desirable property for the build environment, because you want just enough amount of computers, just in time. And then, so the only really way to achieve that, I think, is to have elasticity. Now, back to my cluster, my little cluster in my office. So you can only house so many computers in your office, right? I mean, the heat becomes pretty unbearable, I can tell you that. So what I started discovering that there's this like a room in your building that was called computer lab. Like I didn't originally have access to it, but then I was talking to my colleague, and he showed me how I can fill in this form online and get access to the lab. And then so the lab turns out to be a treasure trove. So I kept adding more slaves from these guys, the lab place. So you see that this computer has like a little yellow tags. So these have like a names to the people who own the machine. And then this is around the time like sun was going down, and so people are getting laid off left and right. And then so when I get into lab, you see all these people's names that are no longer with us. And so I was like, oh, these computers aren't being used. So I turn off the computer, and then then sneak out. And 3 days later, I come back in, and if it's powered back on, then that means I broke somebody's system. And then so somebody cared enough to actually bring it back on. So okay, sorry about that. But if it's still off, that means nobody really is using. People are not really using it. So now I deinstall the system and basically make it mine. So this is my like a zero-budget Jenkins cluster. I can draw these secrets. And then I kept adding more and more, partly because I can, but because I really needed all these computers. And if I think about why I needed all these computers, it's because I needed a lot of different environment in these places. So Sun ships package software. So we had to test our software against all sorts of different environments. It's supposed to run anywhere, but we know the story, right? We have to actually test them to make sure it works. And if you're a service company, then your runtime environment is just one, so you don't have the same problem that I have. But then you still need to test your web app with different browsers, and these browsers only run on certain environments. So oftentimes you end up having all these multiple environments. And then sometimes you really have to keep arcane configurations of the systems. Like I remember, I think one of the slaves that I had to maintain was like a Red Hat Enterprise Linux 5 or 4 or whatever version it is, like a 2 version before. That was supposed to be our minimum system requirement, so we had to test that. That means like we can't auto-update it, so we have to disable them. And this kind of maintaining a precise environment turns out to be pretty painful. And even in Linux, like we had to do the different flavors and so on. So you tend to multiply these environments. And that actually makes the capacity planning even worse. Right? So as a guy who is providing this build environment, like I don't know what kind of slaves people would need. And I don't even sometimes know who's using my cluster to begin with. And even if you ask them, they don't really know, because partly the amount of time they need on these computers depends on how fast these computers are. So if some machine is old, like one of these guys, this is like running a Pentium 4 actually. So you see that they're very slow. So if you run this test on this guy, it takes like about 3 times more than say this guy. And then that means you need actually 3 times more slaves. But so to sort of properly plan for the capacity of this environment and then sort of adjust to the changing demand is actually very, very painful. So either you end up over provisioning and create this like a basically mostly idle cluster that does nothing, or you end up over subscribing, in which case you don't have enough of the computing resources. And you probably have more budget than I did, so you didn't have to go around in the lab stealing people's computers. But I've seen in various places where people created like a large number of virtual machines, each capturing the environment that they need to test. And then, so that looks great. But when it actually comes time to run these tests, the Jenkins did try to run like a matrix project on all the slaves, but it turns out that all the slaves are physically on these just 1 or 2 VMware boxes, and you can guess what would happen. So these are, I think, the real problem people seems to be facing. And then I think this is yet another argument for the elasticity. So you want to be able to quickly adjust to these loads. You don't even want to plan for these things. You just want to be able to react to them quickly. And I think the only way to get to that is to have elasticity so that you could have just enough amount of computers of the right kind just in time. So those are sort of like what I was spending time on aside from hacking code on Jenkins, basically running around in the lab. But there's also the other kind of things that I spent a lot of time on that was, in retrospect, I think is somewhat interesting. So people occasionally knock on my door because they know that I'm the guy who maintains the Jenkins cluster, and they would basically tell me that, look, my builds are broken. My builds are failing, my tests are not running, and then so Kohsuke, I need you to look at that. And by which they really mean, like 50% of the time, what they mean is that, look, it works on my computer, it doesn't work on Jenkins, which probably means the Jenkins is at the problem, right? I mean, I really don't get this mentality, but so those are easy to address. Well, at least technically easy to address. In Jenkins, I build a lot of system over time to basically so that I can prove to them that they are the one at the fault. But sometimes these lead to actually more interesting in real problems. So like one of the cases that I still remember was that there was this test that some people wrote that was launching a Tomcat in the background. And then the test script assumes, unfortunately, that the Tomcat is going to launch in port 8080, which is, I think, the default of the Tomcat. And then so they hard-coded that in the client-side test case. So what they do is they launch Tomcat, and they got a lot of test code that tries to access the server and then make sure the right things happen. Now, it turns out that so when he's running it on laptop, that's totally fine. But if you're running this on Jenkins instance, like one of the slaves, and there just so happened to be another test that also occupies port 8080, then the next Tomcat instance that is going to run will fail. But then actually Tomcat doesn't die. And then so it's not very easy for the test to verify that the server is actually correctly running. So the test client code runs hitting the server, but in this case, it's actually a different web server, right? It's actually running another test. It's a server under the test of another test. So it not only breaks all the test on this side, but it also breaks the other per victim that happens to be running at the same time. And this only happens, obviously, when two things run on the same box at the same time, which makes it a rare condition. So the fact that anytime the test failure only happens once in like every 10 times, you know how hard it is to diagnose this problem. So we spend a lot of time looking into this. And then when I eventually discovered that the cause was this, then I felt quite victorious. And then I wanted to tell another episode of similar thing. Like another guy came in knocking at my door. My build is breaking. Like, can you take a look at that? There's something strange going on. And it turns out that in this case, someone wrote the test cleanup script, which is a progress. Someone was trying to clean up the test, but the cleanup was basically to kill all the Tomcat process in the system. So that's great, but it works perfectly fine if it's running on his laptop. But again, you can imagine what happened if the two Tomcats are running at the same time. And when something is killed by a signal like -9, like it disappears right away. And then so all the tests are failing. But being a good Java engineer, the victim of this like a kill signal would start thinking, well, there seems to be a very interesting problem that occasionally kills our servers. All right, maybe is that like some sort of memory leak that's eventually killing it? Or is there some kind of race condition that's creating a hang? And so they spent all this time eventually to discover that someone else had a stupid cleanup script. So I felt like, but so these things actually happen. So my lesson from there is that I think this is a sort of nowadays widely accepted sort of wisdom in the Jenkins community is that you really need to isolate people's build into individually segregated environment. As a guy who manages infrastructure, or to avoid wasting time on the kind of things that I wasted my time on, you really want to sort of almost treat individual builds as untrusted code. That you shouldn't assume that these people know what they are doing. And in some environment, this requirement for isolation is even harder. Like in the financial sector, so in some services company where they use like a semi-real data to run the tests, they want to make sure that this kind of sensitive information or the sensitive source code does not leak to another build that just so happen to be running on the same box. So sometimes these are actually even harder the real requirements to solve. What's a little bit unfortunate here is that this idea of segregating every build into individual computer is actually at odds with the larger trend in the computing, which is that we are getting a lot of highly concurrent capable large multi-core system. We are not really getting a single core fast computers nowadays. So how we divide up these big multi-core blocks into individually small segregated chunks is still, I think, a work in progress in many ways. So there are some very easy ways to do it. Like, a lot of places would simply divide up these large computers by using a hypervisor, like a KVM or the Zen or VMware. So each gets its own little x86 virtual machine all to itself. That works, but if you've actually measured the performance of these guys, you know that the I/O would suck, and then every virtual machine would have to have their own kernel image loaded, which means you're wasting lots of memory. Again, if you're like a bank, you got lots of money, so you can throw more money at the problem to solve them. But in some other places, these are actually pretty expensive cost to pay. So on another extreme of the lightweight isolation, other Jenkins users are doing, what other Jenkins users are doing is basically creating multiple user accounts on the same box. So like slave 1, slave 2, slave 3, and so on. And then run separate Jenkins slave instance under individual different users. So because every build runs under a different user, you could rely on some sort of POSIX functionality to provide a certain degree of isolation. You can no longer look at the source code, and you cannot kill somebody else's process anymore. But you still have this like a system-wide resource consumption problem like TCP/IP port. So you can't fix those things. So in this space, I think the emerging third approach that's kind of interesting is the kernel containers in what's more well known as LXC or the Docker or Solaris zones. So these technology allows the single kernel to host multiple independent system image, and then so everyone thinks they own the whole world. So the Docker is suddenly becoming popular. So this, I think, is the sort of emerging practice that seems to make a lot of sense to a lot of people. So, but the isolation like this turns out is not enough to solve this kind of all the build failure problems, because I kept getting a knock on the door, people asking me that their builds are not working, and I had to look into these problems. So looks like most of you guys are developers, so hopefully I can actually explain this and then you understand why this is like a real pain in the backside. So I was working with this large shop that has lots of Maven builds going on, like the whole thing was Mavenized. And then it just so happens that there is some artifact. So I guess, actually, let me back up a little. So just for the people who don't know what Maven is, you're in good hands. It's sufficient to tell you that the Maven comes with some dependency management. It's got the mechanism to download the libraries that your project needs. The way they download libraries is that by individually, especially assigning ID to basically all the dependency, all the libraries in the universe. So otherwise known as the group ID, artifact ID, version ID for those is in the secret circle of Maven users. But anyway, so the point is there are jar files that's published under the exact same Maven ID, including the exact same version number, but the content was different. And they're hosted on 2 different repositories. So this is supposed to be like a big taboo in the Maven community, but no one was able to actually detect them because they are in 2 different repositories, right? And there's no way to sort of check them. And really, unfortunately, there are 2 projects in this company that was pointing to these 2 different locations. And then these 2 flavors of the jar files are different enough that if one is loaded, the other guy would actually break, and then vice versa. So the end result, actually, and then one more step is necessary, actually. And then the Maven has this, assumes that the ID identifier is unique. So once it downloads the library, it locally caches them. So the end result is that whoever that gets to run on the slave earlier downloads their favorite copy of the Maven, the jar file, one of these guys, and then you do break the test for the other guys. And then so luckily or unluckily, the guy who operated this Jenkins instance had a script that periodically cleaned up this local cache to really verify the clean environment. So this program would persist for a while, and then the cache gets stopped, and then again whichever that runs fast would win. So now that I know what was going on, I can really explain it to you. But the end result is like the test would randomly fail. And these people are competent Maven users. So they could actually prove to me that if you run the build in a clean environment, that all the tests would pass. So so I really have no excuse but to actually blame on Jenkins. And it turns out that was what's going on. So this one took me like days to clean it up. And it could be happening to you as well. Or take another example. So we have a test script. We looked at the problem of someone who wrote a cleanup script for the test. But if you actually didn't have a cleanup script, or if your cleanup script was incomplete and it doesn't run properly when the test aborts in the middle, which sometimes happens for whatever reasons, and then these things could leave the background daemon processes running on a slave. And when that happens, the process wouldn't die, so it would slowly choke up the memory. The test would slowly start to get slowed down, and eventually like a whole system would become unresponsive, and I have to go power cycle the machine. So these things, I think, are real problems. For me, the lesson is that isolating builds into sort of like a space dimension, if you may. So carving up a big machine into small sections and then letting builds run in each block is a good step, but it was not sufficient. You also have to isolate build in the time dimension as well. You want to make sure that some builds run and then you want to sort of essentially shut it down and then bring it back to the clean state, and then you bring it up and then do some more builds and then shut down and repeat this process. In a way, the slaves are really like human beings. If you're living long enough, you start to develop some problems here and there. Your shoulders might start hurting, and your artery might get clogged. Then eventually you drop dead, and then you kind of have to bring in a new one, right? So when you keep the single slave for too long, you end up spending a lot of time sort of maintaining its health, so to speak. You have to come up with clever script to clean up the temp file system. You might have to have another script to monitor the processes and then make sure to kill them all. There's all these things that a lot of elaborate, sophisticated Jenkins users do, which is great, but nonetheless, it's ultimately sort of irrelevant if you have the good scalability. The good elasticity. That is, this is almost like a definition of the elasticity. That is the fact that you could very easily throw away a computer and then bring in a new one in some known clean state, and then you could repeat it as quickly as you want. So one of the episodes that really made me a strong impression was that we had this thing called Jenkins Scalability Summit in California last, I think, the October or something. And so we had a whole bunch of large-scale Jenkins users in the same room. So these are the people that's counting slave by the hundreds. They have a lot of large deployment, so they had some interesting pain points. So we wanted to understand what they're doing. And so these people are telling us about all these elaborate monitoring and things that they have to do to keep their cluster healthy. Like some of them involve like a statistical analysis of the build success failure rate and some pretty clever stuff. But then, so we asked one of the team that was present was the Netflix team. So these guys actually run their entire cluster on entire Jenkins environment on EC2. And they said, we don't actually do any of these like a sophisticated cleanup or monitoring or anything like that. Whenever we see the first sign of trouble, we don't even look at that, and we just kill the slave and bring in a new one. And only after it persists on the same build, we actually start wasting our own time. So I thought that was really sort of very, very good in that instead of choosing to spend this time writing the monitoring management scripts, they could, by taking advantages of the elasticity, they could nicely basically sidestep the problem. So that, I think, is a good argument for why the elasticity is desirable. So if anything, there seems to be a sort of common pattern of evolution of the Jenkins instance that it follows. So it always starts by someone trying out. So the starting point is always a single Jenkins master, like the one that I had under my desk. But then quickly you realize that you have to have multiple computers to throw out the problem. So you might you might bring in the second machine like I did. These are all physical computers. Maybe it might be virtual, but nonetheless they are static in the sense that you sort of create them and then you keep on to them. You know their names and then so on. But at some point, for all the reasons I was just talking so far, you really want to sort of move on to the environment where you have the elasticity in the slave. That is, you start thinking of slave by the name, but only start think of them as labels, and then you just kill them. Killing the slave is actually not a very good phrase in the United States, but but you know what I mean. You could the fact that you can bring them by a dozen is actually very convenient. And then, so just if these were the convincing enough arguments, I wanted to also make some more cases to what kind of things you can do today if you have elastic build environments. So one of the plugins that I worked on last year is for the parallel testing of parallel testing of whatever framework you had. So I think a lot of people, especially if you're doing a good amount of testing, have this problem of tests taking too long. Right? So individually, any one of the test case might not take too long, but if you're talking about, say, 4,000 tests, like say in the Jenkins project, we got about the 4,000 the tests right now. So the whole thing takes about an hour to run. For us, the hour is kind of long. For many production grade products, I think you might have tests that could take easily days. As I said, when I was working on the application server for some microsystems, the entire test suite would take more than a whole week to run. But that's just because there are so many tests. And then most of the tests, obviously, are written independently, right? So it doesn't really matter what to run in what order. So the kind of obvious thing that the Jenkins could do is that, if you run it once, Jenkins knows where the tests are, and then how long they tend to take. So Jenkins could make a reasonable, educated guess on trying to create sort of chunks, groups, of the tests that have roughly equal runtime. And then so all you have to ask Jenkins is to give me like 3 test groups. Or you can ask Jenkins to give me as many test groups as you want, so long as each is within, say, 10 minutes. And then what the Jenkins would do is it would fork off, in this case, like 3 concurrent builds of your job. And then for each build, we would pass in the list of tests that you want it to run. I mean, the Jenkins want it to run. And then so you have 3 slaves. These 3 things get to run at the same time. And then the Jenkins would also, you tell Jenkins where the test reports are. So they get back and aggregated, and you see the single reports. So all you have to provide in your build script is just the ability to receive the subset of tests to run. And that's a very basic functionality for any test framework. And then so this works equally well with JUnit or CPP unit or whatever that is that you have. And then some of the users, one of the guy from I think the Eastern Europe that's working on a very famous service, they have they said they are dividing up the entire test suite into 10 minutes chunk. And then when we talked, he said, currently our test suite divided up into 26 concurrent builds. So every time a developer commits something, 26 jobs would run on his cluster, and then you get the result within I guess the 10 plus alpha minutes for the overhead it takes. So that I think is amazing productivity gain. If you run the whole thing on the single developer's computer, we are talking about 260 minutes, so that's little above 4 hours. Right? So they managed to reduce the time it takes to run the test from 4 hours to say 12 minutes. And then this time will never increase no matter how many tests they add. So imagine the kind of the peace of mind that it creates in the developer's mind, and the kind of agility that this enables to their productivity. It makes a lot of difference. Now, this is open source plugin, but now I put a little bit of CloudBees hat on. So one of the things that the CloudBees do is to sell this Jenkins Enterprise by CloudBees. This has the support and a number of other interesting plugins. And then there's a whole webinar that goes through all the details if you're interested in. But I wanted to mention about one plugin that actually sort of really leveraged the elasticity in the build environment. That is the validated merge functionality, otherwise often commonly known as pre-tested commit. So the idea is pretty simple. So in most CI environment, the workflow is that the developer would commit to the repository, kind of hoping that everything works okay. Or sometimes he claimed he ran the test, and by which he means like he just tested the thing that he was working on. And then the Jenkins picked it up, and then it does discover the problem. But by the time the problem is discovered, it's kind of already too late. So what the validated merge plugin does is that it basically turns Jenkins into a Git repository. It teaches Jenkins how to speak the Git protocol. So now the developer, instead of pushing the changes directly into this team repository, he could now push the changes into this Jenkins. And what Jenkins would do is it receives the changes, and then it makes sure that it actually is OK by running this entire build or test or whatever thing that you configure. You might have some process in place that the code coverage it has to be above certain number, or maybe another process might dictate that you do not have any find bugs warning above certain level of severity. So you can enforce these things. You don't have to now trust, you don't have to trust your developers. You obviously do, but you don't have to believe in their words. And then the Jenkins, after it verified that everything is successful, it turns around and then pushes the changes into upstream. So while all that is going on, this process could take, the 15 minutes, an hour, or however long it is. The developer could just move on and work on the other things. So it doesn't have to block the developer's productivity at all. So this kind of thing obviously puts a lot of workload on the continuous integration server, because now every commit every push is tested independently. But again, the fact that the developer no longer has to run any test on their laptop, because the break in the build didn't really affect anything. He only gets the notification back, and no one else would see that he even made a mistake. I think it sort of enables a tremendous productivity gain on the side of the developers. So again, all these things are possible thanks to the elasticity. So just to sort of recap so far, as the administrator of the Jenkins installation, there's sort of tangible benefit to you in being able to have elasticity in the environment. The capacity-related issues, the fact that you might have to have lots of different environments in place, and then the fact that you could create enough isolations between builds, which really saves your time. And then for the developers of the system, the user of these infrastructure, you could offer some tangible values as well. Now they could test their stuff in parallel, drastically reducing the time it takes to do it. You could do validated merge. You can also do some other interesting things that I didn't touch, but for example, keeping a slave that causes some build failure on the side, and allow people to remotely log into it to try to diagnose the problem while the other slaves or while the workload is diverted to another slave, or something like that. So, so that sounds, hopefully I was able to convince you why this is a good idea. So now how do you go about creating one, right? So this has been actually done by many people. After all, you saw that every 1 in 5 people are already using lots of slaves. So there's sufficient interest in this space to the point that there's a number of quite solid open source plugins that allows you to create elasticity. So probably the most popular ones are EC2 plugins. I guess those who are lucky gets to do the whole thing on EC2, so they could really simply leverage the underlying EC2 capability. So what this plugin does is, Jenkins is capable of tracking its own workload. It's got the queue, and it can see that there's a lot of things clogging up in the queue. So Jenkins should start thinking, oh, I got so much more work to do, but I don't have enough slaves to throw at the problem. So it turns around and talks to Amazon and get additional computers created. And then it remotely logs in, and it starts using it as a slave. There's another plugin called the JCloud plugin, which is a really unfortunate name because JCloud refers to a library that they're using to talk to the cloud layer. But as a user, you don't really care what library it uses. What you care is what kind of thing it supports. So it turns out that the JCloud supports all sorts of different interesting backends. So in many places, I think there's a now OpenStack deployment or the Cloud Stack deployment, and these infrastructure provides a similar elasticity in being able to create a new instance and destroy them. So it more or less does the same thing like EC2 plugin, but in this case, it's within the firewall, so it probably makes more of you comfortable. And then, so in this way, you can create the Elastic build environment relatively easily. So this I wasn't supposed to demo, but I had some extra backup slide, but for whatever reason it clipped in here. So what I wanted to get there too was here. So I apologize for that. And then similarly, in the Jenkins Enterprise, we built another plugin that's addressed similar elasticity issues. So we noticed that a lot of customers seem to be using VMware as the underlying virtualization technology. And what VMware is, it's not exactly a cloud elasticity technology, but it is actually capable of spinning up new instances and shutting down relatively quickly. And then what's more interesting is that they got the ability to create a snapshot of the virtual machine, instantly destroy the current running system, and bring it back to the previous snapshot and do that kind of thing. So this ability to take the snapshot and bring it back to the existing snapshot is a very useful feature, because now you don't have to know all the gory details of image creation in Amazon or the S3 bucket management and stuff like that. You can just take you can just even manually install the right tools that you want, and then you can tell VMware to create a snapshot, and now this plugin will be able to auto-manage that for you. It also knows, since it knows how to talk to VMware through the API, it could also help you by powering on and powering off the virtual machines as the demand arises and goes. So you could actually oversubscribe your virtual machines on top of smaller number of the hypervisor, and the whole thing would still work efficiently. So this kind of thing I think is really useful. So all these things like EC2 plugin and VMware plugin and whatnot, they sort of relies on the generally available general purpose virtualization technology. But it turns out that if you really set your mind on creating a great slave hosting environment, you can create better ones. Like I mentioned, the VMware, the I/O really suffers, and many build tasks is quite I/O intensive. So for many people, building a custom sort of house for the slaves is not practical, because you have better things to spend your time on, right? But in CloudBees, well, one of the things we do is called DEV Cloud. It's a hosted Jenkins as a service. It's so you can pay us like $50 per month or something like that, and then we provide you a fully elastic Jenkins build environment. So it's really good for small teams. But anyway, so we have this problem at a pretty massive size. We got the thousands of masters we have to host, so we have to provide great elastic build environment, and we noticed all these performance pains. So in the end, we decided that we needed a better slave hosting environment, so we did that, and it's called Mansion. And this is actually very close to my heart, because I was personally involved in this implementing some of these details. So you're going to have to let me sort of brag a little bit about what we've done here. So we call it Mansion because it's a place where slaves live. I had a lot more politically incorrect name, but my colleagues had a better idea. So it's now called Mansion. So they live in a nice place and all. So I think it's probably true with many of the audience here, but in your case, our bulk workload of the build is actually on Linux. And on Linux, there's that container technology that allows us to isolate different groups of processes into their individual universe, so otherwise known as the Linux container. So we get the huge box, like the biggest box the money can buy on Amazon or something like that, and then run a single kernel image on it. And then so at any point in time, we might have lots of different tenants building on the same environment. And if you're deploying a large Jenkins installation yourself, you probably have the same issue. Different product teams are building on your same hardware. But so we wanted to provide the great isolation. In your case, the requirement for isolating this is pretty high, because you're not supposed to see another tenant's data, right? So the Linux container provides just that. All these processes, like a build process and then source code management system and whatnot, or maybe this might be a Tomcat process that opens the TCP/IP port. But everything is segregated into the little corner of the universe. And we could also control how much CPU they get allocated and things like that. But they still run on the single kernel, which means let's say the Maven goes into the download the internet mode, and then it starts doing the lot of network traffic. Then we could quickly divert the CPU to the other build that's actually running the compiler or some sort of static code analysis. So that the fact that we could sort of reallocate the resources in sub-microsecond speed is really sort of help us to boost the overall level of the service to your users. And I think you'll see a similar benefit if you deploy this similar technology on your own. Now for OS X slave, or Windows, I think it would apply. But in these guys, these guys do not have any good container technology, so you'd have to virtualize them in good old way. In our environment, we provide the OS X as a build service to some limited degree, and then we run them on the KVM and QEMU. So we had to, the fact that we were even able to do this is actually a great testament. You had to patch the kernels to make this work and stuff like that. But in the end, it works okay. And then, when you do it, obviously, there's a very high degree of isolation that this guy can provide. Now, this is probably closer to how you do it, and it's kind of costly because every virtual machine needs to load its own kernel. But we didn't stop there. So we discovered this technology otherwise called the kernel same page merging. So what it does is, if you look at individual virtual machines that's running, they actually share a lot of same image. They are loading the exact same version of the kernel, same set of driver, many system services that are the same, probably the same version of libc, blah, blah, blah. So if you divide them up to individual memory page, like a 4 kilobyte chunk or 16 kilobyte chunk or something like that, and then if you hash them, you can easily discover that there are lots of identical copies in there. So what this the KSM daemon does is they go hunt for these duplications, and then they'll try to collapse them into a single page. So even though every tenant thinks they got a lot of memory to itself, underneath it's actually using a pretty small amount of heap on the host. And obviously there's always some small difference between different virtual machines. So you don't get to sort of consolidate them all, but as you can imagine, this results in a tremendous saving. So this is how we could run a lot of the OS X builds on the same physical hardware. And all these work that went into it that is actually only about the CPU. There's a lot more innovation going on in the storage space that we also took advantage of. So to manage the file system, the file I/O is a very big part of the build and test. We are using the ZFS on Linux. This is an awesome technology that I really recommend, not just because this originally came from Sun, so it personally gives me a satisfaction that I'm finally using Sun technology after Sun is lost. One of the things that ZFS does really well is that you can create lots of small file systems inside the single big storage pool. And by storage pool, I mean you could attach however many SSDs that you want, and the ZFS would automatically stripe access to them. So not only you get the single fast SSD, but you actually get the bandwidth of combined SSDs, which is pretty amazing. And so again, say you have lots of different tenants building on your box. You could create lots of file workspaces and keep them around. And then only when it's necessary, you could mount those file system into individual slaves that's in progress. So not only does this provide great isolation, but you benefit from having a warm local cache of the workspace. So if you don't have these guys, you have to check out the entire source tree again. So you can imagine how much time you would waste. Another good thing about the ZFS is that it's a copy-on-write file system. So by copy-on-write, I mean you can create the clones of the file system in constant time. So say, imagine this parallel test use case, right? You now need to run the 26 copies of the exact same workspace and then do the full build. Well, we could actually create 26 independent clones in constant time and then give them to different slaves so that everyone gets to see their own copy, but they all start from the warm workspace to begin with. And the things that are shared, they are actually coming from the same underlying file system objects. So they all share the same kernel cache and there's a lot of performance gain you can get out of these things. And as slaves write back some of the data, like say test reports or whatnot, then these things get stored in the individual workspace. So again, they provide the great degree of isolations. And this kind of technology is not only useful for workspace, but it's also useful for the other things. This Maven repository local downloading the internet program, where you could actually create a pretty large, well-populated local repository that, say, only contains things from central. The things that that safety can rely on. And every tenant can get their own copy of their repository, so whatever files that they install back into this local repository will not corrupt anyone else. So there's a lot of ways you could take advantage of this functionality, and then that's certainly the kind of things we offer. And right now, this service is only available on our cloud slaves, but we are trying to sort of open source the plugin for the Jenkins that allows you to talk to this cloud slave, so that, say, you can benefit from having Elastic OS X build environment on the cloud. And we are also evaluating the possibility of actually bringing this technology, this mansion technology, so that you could install the mansion on your own hardware in your own data center to get the similar kind of Elastic build slave environment within your firewall. So those are the work in progress that I'm kind of really excited about. So, the elasticity, I think, is really sort of useful concept. And then once you get to the point of this having great elasticity in your build environment, I think it's definitely a milestone that, it's almost like a new level of mental peace and new level of enlightenment, if you may. Great. So if you get to that point, like always, the mission accomplished, let's move on to something else. Or does it quite work like that? Well, it turns out that I discovered that the story didn't quite end there, because the case of the elasticity turns out that it's not just for the build slaves. It also actually applies equally well to testing. So this is like, I guess, the US, like a Navy guy testing their fighter jet engines. But it turns out that if you really think about it, most of the things that you're running on your continuous integration environment that makes your life interesting is actually tests. The compiling is a relatively minor workload compared to the amount of testing that needs to happen in the environment. And it turns out that testing is actually a really hard problem. So, one of the sort of traditional attack vector to the testing is to sort of divide things up into small enough chunks that you do not have any external dependencies. Right? So, and then sort of run it quickly enough, and then you hope that when you put everything back together, the whole thing would still function. So that's a very useful test technique, otherwise known as the unit testing. And we all do that, and that's a good idea. The Jenkins project has a lot of unit tests, and then the CloudBees does the same. But obviously, that's not nearly sufficient. But on the other hand, the testing the whole system is often very painful, or even the testing just a subset of the system is often very painful, especially in this day and ages where all these services and programs need to be connected to something else. Jenkins, if you're talking about, I used to write a compiler, which is a really nice, isolated piece. A compiler only interacts with some input file and output files, right? So there's really nothing in the environment that I need to simulate to really test compiler to any serious degree. So I could write lots of tests, and I could run them in as many parallel as I wanted. If I wanted to run it in 26 different parallel tests, I could have totally done it. But if you have a test that needs to have a running database, then do you actually have 26 database instances that you could test at the same time? Well, do you have your services might need some front-end load balancer. We had some bugs in the CloudBees where the load balancer affected the services in the back end. These problems happens. But do you actually have the 26 copies of the load balancer in your environment that you could use for testing? So the fact that now that you have this elasticity in the build environment, you'd actually start to notice that the next thing that's dragging your productivity gain is that the lack of elasticity in the test environment. You just can't have enough of them. So I think there's in our industry, there's really only two ways to deal with this problem. The one is to substitute the real thing with a fake thing. It kind of looks familiar, but then doesn't really have the same name. I love this Chinese creativity there. And then on the other side, okay, this is someone doing I think the civil engineers doing the earthquake testing on the building structures. So they built actually the mock-up at the real scale. I'd imagine this is costing some serious amount of money, and it gets distracted 15 minutes after this. I really want to be at this place when it happens, but I have never managed to do it. But I think the similar thing happened in the software industry. We spend a lot of time trying to create sort of the mock or the substitute of the real thing, like a real runtime environment. So in Jenkins project, for example, to test a subversion plugin, I need a real subversion server, right? That has some interesting data in it. So I had to write a lot of code that sort of drives the subversion server, starts it at some random port, and then feed the data that I need so that I could run some tests, and then I throw things away. And that takes a lot of time. And then subversion server is actually one of the easier things to automate. I had to, so far, we haven't written any test on, well, maybe I shouldn't say this, but we haven't really written any real tests on the LDAP plugin, because now I need a functioning LDAP server that contains some data set. Right? And then those things are really hard to automate, or I cannot create like an actual portable test that any of the LDAP plugin developer could run. So it really takes a lot of time. There's an even better example. I have some real tests on the Active Directory plugins, but LDAP, at least I could conceivably run the LDAP server. But the Active Directory, I have no hope of automating it whatsoever. So I actually have a virtual machine that contains just the data that I need. And so if I die on the flight back to the US because the plane drops, then there will be no test for Active Directory plugin, because I'm the only guy who knows how to run those tests. And I think these things actually happen in the real life, because the test environment is so tricky to reproduce. Now, if you think about what they are really doing, the act of emulating the real environment will be a non-issue, just like managing the cluster was non-issue for Netflix people if your production environment is elastic. This morning I was talking to people actually doing hardware, and I could totally see why they can't have elastic runtime environment. But luckily for many of our professionals, many of our software industry, we could actually have the elastic runtime environment. You could actually have an elastic database that allows you to spin up 26 databases at the same time, or 26 load balancer at the same time. There were whatever many things that you need in your services. So if you think about like what is it that allows you to elastically scale these individual pieces, I think I'm sorry, I'm getting ahead of myself here. So then I think this, so if you think about what it takes to create 26 identical copies of the load balancer, for example, I think a part of the problem is to be able to sort of lay down the configuration in a certain known way so that it always gets in the same space, right? And then you just need to repeat it 26 times. And then this is otherwise known as the infrastructure as code. And this, I think, is now a well-established idea that many people know how to solve. Right? I think many of us have written chef recipe or the Puppet modules to deal with this thing. But this actually isn't, in my mind, is not the whole story. The actual hard part is, is that you have to get the 26 machines to be able to run chef recipe 26 times. So the fact that what you're really looking for here, what I think is the other real challenge, is the elasticity. Now, I work with Chef Recipe. The CloudBees uses Chef for our production servers, but I discovered that the Chef doesn't seem to really help me sort of create 26 environments. Or if you are thinking about, say, a network of the components that needs to talk to each other, and then I need to instantly create 26 of them and then throw them away after 15 minutes, it doesn't really seem to help me. So the similar, but I think the benefit of this, I think, is obvious. The fact that you could run so many tests in massive parallel scale that your tests have the portability is quite useful. And then, so if you notice, this seems to have the exact same ladder of evolution that we saw in the elastic build environment. in many places, you start with a single production environment, right? And then you test in production. Like, I don't do testing, but when I do it in production. Many PHP people still do that. I don't do it just to make sure, right? The CloudBees don't test in production, but if you look at many of the PHP shops, they still do that. And then, if the problem happens, you can just roll back. But I think most of us actually recognize the need for having multiple environments. But the point being that these multiple environments are still static. So you might see in many places they have a dev instance and a dev environment, and then staging environment and production environment or something like that. A fixed number of static environments that people use carefully. But that doesn't provide elasticity. So if someone is working on the dev environment, and if you want to work on the dev environment, well, tough luck. So the same argument that I think drove us from the static slaves in the context of build to the elastic slaves, I think equally applies to the runtime environment if you really start thinking about testing as seriously as you do the production. So, and then this notion of elastic runtime environment, I think, and then being able to spin up 26 databases at the same time actually is almost like the definition of the past to me. You could spin up 26 Amazon instances and figure out how to wire them. It's so much easier if you're actually talking at a little bit higher level. So that's actually sort of nowadays when I think of the CloudBees, we have this runtime side of the offering that does the pass, and then on the development side of the offering that does the debug cloud and JE. I think they seems to sort of work really well together. And then if you take this idea to the logical conclusion, it seems to be that the only place that you end up would be this having elastic environment for both your build and runtime. So that's the idea that I wanted to convey in this talk, and so thank you very much. So I guess we'll be taking questions, I assume. Anything I could.
So, questions.
This is always a nervous moment.
For which programming language is Jenkins being mostly used?
Yeah, so I think it's fair to say that the Jenkins is most frequently used on the Java project, just because of like a default list of packages, default list of plugins that we bundle is created for Java. And for people who are using Java, the Jenkins is extra useful because they could write their own plugins to make it useful. So when we did the survey, I think the Java was indeed the number one. But there was surprisingly large number of people that was doing C and C++ development. I think if I remember correctly, that was about 60 to 70% of the size of the Java people. And then the next one from there is like the usual suspects, like .NET and Ruby and PHP and so on. So I think it's safe to say that it's used by quite a diverse environment. It's partly due to the fact that in many places, a single company does lots of different languages, right? So that's what I saw.
You collect these statistics, and can they be seen where?
Yes, so this is a result of the survey. So we asked people like what language you're using, and they answered. And I forgot exactly which URL it is, but if you search Google with Jenkins survey result, it's somewhere on jenkins-ci.org, so you'll be able to find it.
You mentioned setup with a huge number of slaves. Is there any work being done in the direction of slaves being used by multiple masters?
Is there any, I'm sorry.
Is there any work done in the direction of slave being used by multiple masters?
Yeah, in some places, the single slave, technically you can use single slave from multiple masters. It's just that the multiple masters the master don't know that the other master are using that slave, so they might end up doing less than optimal scheduling. But aside from that, nothing prevents you from doing that. You just need to give them different home directory. Or maybe, was I missing a question?
No, actually it's about...
Okay.
Because you can talk about sharing as well, because it's in the same.
Right. So I think he wants me to talk about our commercial offering that I always stumble upon. But all right, I try to be a good salesman here. So the other thing we do, the other thing we do. So this is what we do in the another product that we do called Jenkins Operations Center that we released last December. So I'm kind of still excited about it, where you could. Because masters don't talk to each other, to do a good scheduling job, we need another layer. So we created this master of masters, just like in a single master control lots of slaves. You have a Jenkins Operations Center that could control lots of masters. And then when you attach slaves to this Jenkins Operations Center that we called it jockey, because it's easier to call, that would be able to sort of basically hand out the slave to individual masters. So if you're really thinking about using a single master with single slave with multiple masters, something like that effectively does the coordination between different masters. But was that your question? I'm still not sure if I got your question all correctly.
I have to think a little bit how to.
Okay. I apologize.
So you mentioned on one slide how you benefit from ZFS file system. Are there any plans to support the same for Petri file system?
Yes. Well, okay. I don't have any plans, but I actually looked at that when we were working on designing this whole thing, and so some of the functionality the Btrfs does provide. You can create a constant times clone in Btrfs, but there are some really critical features that it's lacking. One of the things the DFS is good at is being able to take two snapshots and compute the difference in the time linear to the amount of difference, and then I could ship that over to another computer. So in the case of, say, 26 slaves, I might not be able to run all the 26 builds on the same box. I want to be able to distribute them. So what this ability to take snapshot lets me do is, well, this box has a little bit older snapshot here. I actually want to start a build from here. So I compute the delta, send it over, and then start the 13 of them over there. So this kind of thing is really handy to do, but not available in Btrfs. And I don't like Oracle, and I like Sun. So, but on a serious note, I find the GFS to be more functional in many ways. So this snapshot transferability and the fact that it could utilize lots of underlying storage pools very well. So these things made a difference. Sorry if there's any Oracle people, I love you.
One of the questions in the survey was what people would like to see as an improvement or what's coming next, basically. So how's that affecting what you do and what CloudBees is doing?
Right. So there's a lot of things that the people want to see. So we talk to them and then try to find them out, and then we try to figure out the way to do it in open source. One of the big efforts in this year, in my mind, that I was actually hacking on the airplane from the San Francisco to here, is the workflow support. Some of you might already know about a build flow plugin or the job DSO plugin. That's where people are trying to choreograph lots of different activities in Jenkins to say create a continuous delivery pipeline. You look like you're lost, so maybe I'm explaining it very poorly. So let's see what would be good enough. Yeah, so say you're working on a website, right? So you might have a build that generates a web application, and then the next step is then you run some unit tests, and if that's good, you then want to actually run this web application, deploy it somewhere, so that say you could run a battery of Selenium tests on it. Maybe you actually want to deploy it in 4 places so that you can run 4 different copies of Selenium test at the same time. If they're all good, you're going to shut them down and then take that application and wait for, say, designer review or some sort of a database scheme update review. And then if that passes, then you want to deploy it to, say, staging environment where some selected external people could look at and then give you OK. And if that's OK, you might go to the production environment. So people doing, say, web development, this kind of workflow is very popular. And then they want to automate the entire thing on Jenkins, which is doable today, but it's less than optimal, shall I say. So people wanted to be able to get the ability to describe the whole thing in a more concise way and then get the visibility into how things are happening where and so on. So I call this kind of thing the workflow. And there's a lot of heated conversations about this in the Jenkins Scalability Summit. So that's actually something I'm planning, we are hoping to work on. We are really planning to work on this year. And then, some portion, that will be done in open source. So there's a lot of work to be done. There's another effort that's going on in the community right now is the LTS, or the stability improvement effort. So again in this Scalability Summit, and after talking to lots of Jenkins users, we discovered that in many large places that uses Jenkins seriously, they do certain kind of acceptance testing before they decide to upgrade to a new instance. They take the new version, they install the plugins that they're using, and they actually put the kind of the workload that they're using it for, and they make sure that the things run okay. Now, unfortunately, these things are in many situations. This is happening inside the corporate firewall without any visibility to the project team, and then so we wanted to fix that. So as a first step, we revisited the release cycles of the LTS. Previously, the way the LTS release cycle was determined was that we kind of had some goal. Like we wanted to try to get release out a new LTS release out every 3 months. But that was only like roughly speaking. And then when we looked back at actually what has happened, sometimes it's like 5 months, sometimes it's 2 months. It's somewhat unpredictable. So we just fixed this process to really turn that into a train model. So we actually committed a particular date. You can, if you're really interested in it, you can read this on our website. But the 12-week cycles that sort of set the dates for the key milestone, like RC dates, which is the window of the time where we can take backports. So some of the people, they need to be able to backport some specific bug fixes. And then this fixed schedule, for example, allows them to plan their upgrade process well without the LTS release process. So it creates more predictability in the process. Another thing that we are hoping as a result of it is we are trying to sort of come up with common test harness that allows this acceptance testing to be written. So there we need to be able to say, well, we need these plugins installed. Well, assuming that these set of plugins are installed and then these number of environment exists, we run this test and then make sure that it works. There's already some test like this that's written in the Jenkins project that's named Selenium test. The name is a little bit unfortunate, but it does a whole lot more than just Selenium test. So we wanted to take that and then enhance it so that it could be used as a mechanism for people doing acceptance testing to write their test cases. If people are writing common test cases in the common format, that would allow the companies to share their tests with others. Right? So when the Yahoo writes the test cases, the Netflix could run it. When the Sony Mobile writes a test case in that harness, then I don't know, whoever else could, or BMW could run them. So I'm hoping that it will facilitate the collection of the tests to appear in the community. And then so this is where we are putting lots of effort in, and then I'm hoping to sort of really rally the community behind this. So that's another, I think, effort that we are trying. So there's a lot of big and small projects going on in the project. And unfortunately, this being open source means that ultimately at the end of the day, I can only encourage people to do certain things, but normally the community does like something else that whatever they want to do. So the leverage I have is somewhat limited, but at least the CloudBees has some people that's working on the code. And I think, I'm kind of hoping that the kind of thing we are trying to encourage people to work on is a real problem that hopefully you'd agree on. Then we'll be able to, I think, make a real difference. So that's, let's just maybe do that. Hopefully that would sufficiently cover the higher order bits. So I'll leave it at that. Any other questions that I could help?
I'm not a specialist on continuous integration tools, but I am assuming that there are, or I know that there are other tools on the market. Well, non-market because they're public domain. Would you dare to make a couple of statements about why you think that Jenkins sticks out with respect to push control, or the others whose names I do not know. I mean,
Right, okay.
if I were to choose one tool, why would you heartily recommend Jenkins?
Right, yeah, okay, okay. Yes. Wow, thank you. So I think to me, the one key benefit is the sort of size of the ecosystem. So this is not backed by a single vendor. It's backed by the 800 people in the community, more or less. And that is, it has its downside, but I think it sort of really sort of creates this sense of, there's a safety number in computing. Like the reason Java is so popular is not just because it's technically good, some would disagree, but the fact that so many people are using it, there's a large ecosystem, some commercial offering and some vendors providing something. There's a large pool of people who know stuff, and there's a large Google footprint where when you got any Java questions, you can just type that into the Google and you find the answer in 5 seconds. That's the kind of thing that really making Java ecosystem useful. And I think the same applies to Jenkins. When you got so many number of people working on, in the committer in the TNG consulting writing some plugins, or the people writing books in German or in Japan or whatever, that creates a large ecosystem that sort of makes a lot of things easier. So that's one. So there's a safety in numbers. Another thing I think is very key is the extensibility. Everywhere I go, I discover very different process, very different kind of software being written. It almost seems like no two companies seems to do things exactly the same way. So to be able to cope with this kind of diversity, you really need to be able to tweak things, the way I often describe it is you need to be able to make Jenkins speak the language that your product team understands, like all these acronyms that they throw, right? All these processes that they've learned. You could, when you can write plugins in Jenkins, anyone could write plugins in Jenkins. 850 people did it. It can't be that hard. When you do it, it really sort of, you can create a solution that's custom tailored to your environment. In large places, that's really very practical to do, so there's a lot of benefit you can get out of it. In small places, it means, even if what you're doing is esoteric, you can almost always find some combination of the plugin that sort of approximates what you're doing. So this ability of being able to extend the code and then being able to see all the source code that's underneath and then get stuff done, I think is a tremendous benefit. And lastly, it's free as in beer. It's like I guess free as in speech. Like it's kind of hard to beat the zero price tag when you're trying to do this stuff. So I'll probably mention those three as the key factor.
Maybe I have a short example for this. So we are just about to migrate from a 5-server cruise control environment to a Jenkins build farm. And we have the feeling of jumping off a bike and getting into a spaceship. So it's a matter of configurability, of documentation, of scalability, and so on. So from my point of view, it's really hard to compare a cruise control to Jenkins, even because we really are making very good experiences with Jenkins.
Right, so I guess it sounds better when it comes from somebody else than like the guy who's doing doing the project. So, and I didn't pay him beforehand, just so you know.
So we can also confirm that if you need more confirmations for that. So I just can recommend Jenkins. I used it for 5 years and we also elaborated on other systems.
I think the challenge is almost that it's too flexible, so people get confused with the flexibility they give them if you ask them to use it.
Yes, that's true. Yeah.
It's always a challenge on that side.
Yes. So the fact of, in a way, I mean, it's when I originally set out to write this like a extensivity system, plugin system, I didn't imagine there to be maybe 20. If I got like 20 plugins, I thought it'd be awesome, and I didn't imagine that it would get anywhere near this size. So you're definitely right that the amount of diversity is sort of giving you almost too many choices. So there's an interest in trying to address something like that in the community as well. So for example, we do know actually that through the people who participate in the anonymous usage survey, we know which plugins are installed together with what other plugins and so on. So there's some data to be mined from there. So I'm kind of hoping to one day manage to get into the Google summer of code. apparently like a Google and the Sun has a problem. You know that now what became the Android lawsuit issue. So when we are doing this project under Sun, the Google never took us under the Google Summer of Code, but now that I think there's a fair chance of doing it. And then we can get some really smart grad students for free. And then this I think is actually a fun problem to work on. You got lots of interest, relatively large data set, but still something you can hack on. And then some actual tangible benefits that you can get out of it. There's a lot of obvious ideas like this, recommending the similar plugins or coming up with some sort of review system so that the people could vote on things. We can also tell when people upgraded and downgraded and when they stop using it and installing some stuff. So again, if you look at data, I think we should be able to infer a lot of things about, well, which plugin appears to be popular, which versions might be having more problems, and that kind of things. So I want to be able to do all that, and then that's one of the 100 other so obviously right ideas that we should have already implemented years ago, but it's all in the backlog. So that's a challenge. If you know some like a good grad student that wants to hack on data mining project, please send it on my way. Any other questions that I could help?
You said you had this on, so the build distribution with ZFS, you had it on OS X.
Right.
Do you also have something for Windows?
Yeah.
It's a struggle to have to run many tests.
Yes. Yes and no. So I did prototype on Windows, and then actually the Windows is kind of interesting because it's got more virtualization drivers. So I actually can get a lot better performance out of Windows, and then so. We figured it out to the point that we know it's technically feasible. But then we have to actually learn about the arcane details of the Windows licenses, and at that point I started hurting my brain. And so I thought, well, let's just focus on the OS X first, because when I talk about the OS X, more people's eyes light up because of all the iOS-related developments that's going on. And the virtualizing OS X is actually still a pretty hard problem. Compared to that, the virtualizing Windows, it's a very easy problem. And then, so when I talk about Windows virtualized slaves, people, okay, well, I can do that on EC2 on my own. So that's where we are. But so if you're one of those few people where the eyes light up, I want to hear from you so that we could prioritize accordingly. Or if you have a guy from Microsoft, please tell me how the licenses work.
Okay, thanks.
All right, thank you very much.
We have another 15 minutes, so if you're curious to learn more about CloudBees, Jenkins Enterprise Operations Centers, all the topics not covered in talks, we can now, or you can now ask the experts like Kohsuke, I think Stefan Wolf, who is Jenkins committer, also the people from CloudBees or TNG, if you're curious for some other questions regarding all this.
Yeah. I don't know many people who are running Mac OS in a virtual machine. I've heard about it. Some people said it's difficult. You mentioned it. Can you just say how much work is it, or what's the problem with it?
Well, so let's just say it involves my compiling kernel. I have to patch KVM and QEMU. So you're welcome to try, but I said, I like challenges. It's a involving work, and that's why I think it's more valuable for the graphics actually to offer that as a service.
I mean, just as a remark, I'm interested in it for security reasons.
Yeah.
I'd like to run a version of macOS in a sandbox in order to isolate from certain bugs or Trojan horses or whatever.
So I think, so it's doable. I mean, so I've done it, and I know other companies like Source Labs, for example. I know they've done it. There's patches lying around on the internet, and you can find all the gory details about the ACPI, DST tables, and some stuff. But look, you got better things to do with the time, I can tell you. Really. So if you really want to know the gory details, I can give you some pointers. But to actually put things together is a good chunk of work.
Well, if I can add to that, it's really not that difficult, but there's a business reason. It's not allowed to use Apple software non-Apple hardware.
Yes.
So no big virtualization company supports this. There's a version. If you're running an Apple, then it's easy. You just install firmware Fusion or something. So this works out of the box. I'm doing it well at work. You just want to hear he's running it on HP hardware.
Yeah, so you have to buy the Apple hardware just for this purpose. It's crazy. So if you're from Apple, please, but I know you're not.
Any further questions, or everybody wants to go to the food?
Yeah, it's kind of hard to stand between two and people. That's true.
Yes, of course.
Are there some screenshots or some demo of this joking?
Of what?
I didn't hear.
Operation center?
This operation center.
Are there some screenshots or
some demo for the
Screenshots.
operation center.
Okay. Well,
Have you run it?
no, it's screenshots.
We have we can send over. We have a product description flyer on it.
All right, so it's
Maybe that's easier. So if you give them your email address or something, then you get all the full-blown marketing stuff.
But you can speak maybe a little bit about it.
Yes, so I can certainly speak a little bit about it. So the Jockey, the way it's built is actually just a whole bunch of plugins on Jenkins. So if you look at the screenshot, you'd almost think it's just another Jenkins, except for like a logo on the left that says where it normally says Jenkins, it says Jenkins Operations Center like that. And then so you can attach like a slave, you can create like a shared slave, you could register the master that's connected to them. And then you link up the master. So it would almost look like the dashboard page of Jenkins. And then, so you write that code.
Also, you can go on the website. The CloudBees website is fully.
Right.
Okay. You can show it.
Yes.
Do you have access to it?
You can show. Maybe show them the trial download link as well. If you would like to test Jenkins Operations Center, there's a free evaluation version that you can download for free. So it's a full feature for 30 days, so feel free to test it out. But Kohsuke, it would be required to download the evaluation of Jenkins Enterprise as well, right? To do the attachment of the masters to the jockey, correct?
Yeah, well, you'll see these document instructions on the user guide. So I don't want to go too much into the details, but there's a so.
So any further question?
On that operation, what you're showing right here, this I looked it up before. So basically, it's about sharing of bit hosts. So you have
Yes,
you want to share across.
right.
So is there any idea of going a step further and sharing more than bit hosts?
More than so what it does, so it does share the states, and it also gives you the sort of like a central place to hook up all the Jenkins instances, so that your users didn't really notice that you're going between different masters. So you can kind of use it as a way of creating large model scaling. There's also like a security-related features where it's here, so that you can have a role-based access control that's centrally managed by one team. Or like your corporate policy would probably say like a whole thing needs to be authenticated through Active Directory or whatever. You could enforce that from Jockey, so that's part of these features. And then it has a single sign-on. It enables single sign-on across all the Jenkins master instances. So again, in places that you have lots of Jenkins master, you only need to log in one place, and then you get to be you in all these different places. So, or it has a custom update center. Yeah, basically, let's talk about the custom update center. So, if you're developing, if you're big enough place that you're developing custom plugins, then you don't currently really have a viable story of deploying this plugin and master all your Jenkins instances. So you could do that. And the same mechanism actually allows you to sort of control the visibility of the plugins from the OSS update center. So say if you're doing acceptance testing of the plugins as well, then you don't want these instances inside your company to randomly install random new versions of the plugins. So you could control this visibility by saying, for example, like, we tested some version plugin 1.35. So I'm not going to expose anything more than 1.35 until I do the testing. So you could set this policy, and then all these connected Jenkins master will basically apply. So that's sort of some of the key highlight functionality.
So it's so Jenkins Operations Center. It's launched back in December. So it really is our reaction to the enormous growth of Jenkins within organizations. So it's launched in December and it's already flying off the shelves. It's putting it very positive, but a lot of companies have interested in it, and if you want more information about it, so when you use Jenkins in your organizations and you have scaling issues or you have multiple Jenkins masters that you want to manage in a centralized manner, then we are here with TNG and we can help you with it. Yeah.
So, I would say it's time for lunch. Thank you all for coming. Thank you for your interest. Thank you, Andreas, for organizing the event from the TNG side. Thank you for you coming extra to Munich and giving us such a great overview and such great talks. Thank you. And please eat something outside, we paid for it.